A helpful hint here about the signs of your factors. If you look at the signs of the trinomial, if the last sign of the trinomial is positive, that constant term, then your factors have the same sign. So that sign will depend on the middle coefficient, b. If b is positive, then both signs of the factors are positive. If b is negative, then both signs of the factors are negative. If the last sign of your trinomial is negative, then that means your factors have different signs, and the bigger number will be the sign of the coefficient of b. So let's use that hint as we factor some polynomials. Our first example here, x squared plus 13x plus 30. So we are looking for factors of x squared and factors of positive 30, such that the sum of the products of those factors is the middle term, a positive 13x. So factors of x squared can only be x times x. These have to have the same exponent for both base x's. And factors of 30, there are many factors of 30, right? 30 could be 5 times 6, it could be 10 times 3, it could be 30 times 1, or 15 times 2, okay? So we have a lot of options. We can choose whichever ones we want to try. Say I want to try 5 and 6. Since this sign is positive, that means that the factors have the same sign, and that would be a positive sign, so positive. And if I multiply across x times 5, I get plus 5x, and x times 6 is plus 6x. Does that add up to 13x? No, it doesn't. So let me try something else. I do still know the signs are both positive. So let me try other factors. What about 10 times 3? Multiply across, that's a positive 10x and a positive 3x. And that does add up to 13x. So that means I have the right factors. So how I'm going to take those factors is diagonal terms. So one factor is x plus 3, and another factor is x plus 10. And if you want to check, you can always check your factors. That will definitely help if you make a sign error. So you just distribute each term to each term. So x times x is x squared, x times 10 is 10x, x times 3 is 3x, and 3 times 10, that's 30. So that'll be x squared plus 13x plus 30. That checks out with the original polynomial. So that proves that we have the correct factors here for this trinomial. Our next example, we want factors of x squared and positive 24, such that the sum of the products of those factors is negative 11x. So the only factors that we can have for x squared is x times x, same exponent. But 24 has lots of different factors, 2 times 12, 24 times 1, 4 times 6, and 8 times 3. So which factors do you think are going to add up to 11? Possibly the 8 and the 3, so let's check that out. This sign is positive. It means we have the same sign for our factors, and this tells us that sign is negative. So if we multiply across, we have a negative 8x and a negative 3x, which does add up to negative 11x's. So let's take those diagonal terms, an x minus 8 and an x minus 3. Those are the factors of this trinomial. We can always check by multiplying them back together. Another trinomial we want to factor here, so factors of the first term and the last term, such that the sum of the products of those factors adds up to the middle term. So factors of x squared have to be x times x, And 35 has some different factors, 35 times 1 or 7 times 5. So I'm going to try 7 times 5. That might add up to what I need. Let me get the signs. So they're different signs. And this tells me the bigger sign, or the bigger number, is negative. So 7 is bigger than 5. So if I use a negative for 7 and a positive for 5, does that add up to negative 2x? Yep. So that gives me my factors of x plus 5 and x minus 7. I can double check those by multiplying the factors together to get the original polynomial. Another example here, we want to factor x squared minus 6x plus 10. So we're looking for factors of the first and the last term, such that the sum of the products of those factors is the middle term. So x squared has to be x times x, and 10, let's see, that could be 10 times 1 or 5 times 2. That's it, right? Okay. So let's try 10 times 1, same sign, because it's positive for the last term. And that means they're both negative. Okay, so a negative 10 and a negative 1 gets us negative 10x, negative 1x. Nope, that doesn't work. So let me try the other factors. All right, 5 times 2. They're the same sign, they're both negative, so minus 5x minus 2x. That does not add up, so that's out. Are there any other factors of 10? Well, if we've exhausted all possible factors and none of them work, we have to be sure that we've exhausted all the possible factors. What am I doing? I can't spell possible, can I? If none of the factors work, then that means we can say something special about this polynomial. And that is that it's prime. Do all positive integers have factors other than 1 in themselves? No. Like 2? It doesn't have any other factors except for 2 times 1. 3, right? All of the prime numbers don't have any other factors besides 1 in themselves. So do you think all polynomials have factors other than 1 in themselves? And that's what we saw in that last example. Some are going to be prime, but you cannot say that unless you've exhausted every single possible factors that don't work out.